Alright, so in this video we go over briefly section 8.1, right triangle trigonometry. Well, so far we have looked at trigonometric functions as values that lie in the circle of radius r, in which the x-coordinate represents the cosine function and the y-coordinate represents the sine function. Now we're gonna use that same type of thinking, but now, well, here is what we used to have. Okay, the point on a circle of radius r. Well, in this case we're gonna have a radius, well, not a radius, but because that letter c is no longer going to represent the radius, so rather we are going to have a right triangle in which we are going to establish the position of a reference angle. In this case is going to be this acute angle. The side that faces the angle is called the opposite, and in this case A, which is called the adjacent, which ultimately, I mean, if we think of axis, this is the x-axis and this is the y-axis. So really, if we define the trigonometric functions as the sides of a right triangle, well, these are still going to be the same. Well, sine, which is y over x, you know, that's y over x. That's opposite over hypotenuse. That's y over, no, not y over x, y over c. You know, if this is the radius, you know, y over c. Cosine, it's the adjacent, which is the x over c. That is the adjacent. And tangent is the y over x. Remember from the unit circle, tangent is defined as y over x. So that is the opposite over the adjacent, that's b over a. And of course we have the reciprocals over here. Alright, so let's find the exact values of the 6 trigonometric functions of the angle theta in the figure below. Well, so for example, we have this reference angle. We need to find the length of the opposite side, which, by the way, we are going to use the Pythagorean theorem, right, which is a squared plus b squared equals to c squared. I mean, we're talking about, so this is c, this is a, and this is b. The opposite is b. All right. So we know that a squared, that's a 3 squared, plus b squared, we don't know what b is, c squared equals 5 squared. And I think we have done this a few times, so that's a 9 plus b squared equals 5 squared, which is 25. B squared equals to 16, and b equals plus minus the root of 16, which is plus minus 4. But in this case, we take the positive because, I mean, in this case, we can just skip the negative value because we're talking about the side of a triangle, which in this case has to be positive. So what are we going to do in this case? Well, let's write sine theta, cosine theta, tangent theta, cotangent theta, secant theta, and cosecant theta. Well, sine, which is opposite over hypotenuse, that's a 4/5. Cosine, which is adjacent over hypotenuse, that's 3 over 5. 3 over 5. And then tangent, which is opposite over adjacent, that's a 4/3. And then cotangent, secant, and cosecant. Keep in mind that cotangent is the reciprocal of tangent. Well, that has to be 3/4. Secant is the reciprocal of cosine. That has to be then 5/3. And finally, cosecant is the reciprocal of sine, which is 5 over 4. And those are the 6 trigonometric functions for this right triangle. Now, in the next page, what we briefly do, it's one example of solving right triangle. So what does it mean to solve a triangle? Well, so to solve a triangle, so we are going to be given some information like a side and one angle, and then we're going to use the trigonometric functions and the Pythagorean theorem to find the remaining, the remaining parts of the triangle. So this is what we are going to do. Let's list, okay, small a, our lowercase a, lowercase b, lowercase c. Those are going to be the sides. And then in this case, well, the uppercase letters are going to be for the angles. All right. Well, they're giving us that a equals 40 degrees. All right, a equals 40 degrees. And well, what about from here, from the picture, we can tell that C is 90 degrees. Why? Because C is facing the angle big C, and you can see here, we can see actually that this is 90 degrees. We can find B. Find B by difference. Well, we know from basic geometry that the sum of these three angles has to be 180 degrees. All right, the sum equals 180 degrees. Well, so we can find B by difference. Well, 180 minus 90, that's 90. 90 minus 40, that has to be 50 degrees. So we got the, okay, let me make this look like a 5. Yeah, it looks like a 5. So we have the angle part solved. So part for the sides, well, they're telling us that B equals to 2 and B equals to 2, and what else? This is A also. Well, A, because A, this is the angle A. The side that is opposite to that angle, in this case, is 3. We need to find C, and we get that by A squared plus B squared equals C squared. So A squared, which is 3 squared, plus 2 squared equals C squared. Simplifying this, we get 9 plus 4 equals C squared. So C squared equals 13. And C equals plus minus root of 13. But again, in this case, we're talking about triangles. We take the positive solution to the equation. And that's what it means to solve a triangle. Of course, in this optional section, well, I'm just briefly want to introduce what solving a correct triangle is, but what we really care about is what happens when we have, I don't know, triangles like this. How do we solve them? Because of course, yeah, we have a big angle BA, BC, then little c, little a, and little b. In this case, this is not a right triangle. So in this case, Pythagorean theorem and the sum of the inner triangles, well, the sum of the inner triangles may help at times, but not always. So in this case, we're going to use what we call the law of sines and the law of cosines. And to get that, make sure to look at the next video.